Alright everybody, we're on lesson number 2. Again, I'm doing notes just because my textbook is a bit messy right now. So first, this is on page 599. There we go. Okay, so it's solving second degree trig equations, which essentially means we're solving quadratic equations with trig. I know everybody's freaking out right now, but if you remember quadratics from grade 11, this is a quadratic equation. To solve this, we factor. We always factor. So it's what multiplies the 2 and adds the 3. That'll be 2 and 1, so it's x plus 2, x plus 1. So we just solve each bracket, so x is equal to negative 2 and negative 1. That is essentially what we're doing. We're just combining it with the other trig stuff we did earlier. So before we move into that, we have to review factoring because it's pretty much the first step to every question we do. So again, this is on page 599. The first example of factoring we have is 8 tan a plus 4. Now look, if you don't like the trig stuff, you can substitute it out. So you can just say, let x equal tan of a. So then I turn this equation into 8x plus 4. And if I ask you to factor that, you would say, well, pull out a common factor of 4. And I'm left with 2x plus 1. And then put back in what x is. So it would be 4 times 2 instead of x, we write tan of a plus 1. There, we factored it. You can do that every time you want. The second example they have is sine squared x minus 3 sine of x. So just a note on notation here. When you see the square on the sign, what that means is the whole thing is being squared. Okay? So again, you can substitute out the trig function if you don't want to. You don't have to, all right? I will not do it when I'm doing examples, but for this, if it helps you, you can use any letter you want. We can say, let a equal sine of x. So then I end up with a squared minus 3a. How do you factor that? Pull an a out. Then let's with a minus 3. Put back in what you said a was, sine x. So this turns into sine x minus 3. All right. So a third example is 4 sine squared x minus 1. Again, we'll get rid of the sign. We'll just call it a. So I get 4 a squared minus 1. Now, some of you may remember, some of you may not. This is a difference of squares. Two terms separated by a minus sign, and you can square root both of them. So it turns into 2a plus 1, 2a minus 1. Put back in what a was, 2 sine x plus 1, 2 sine x minus 1. All right, the fourth one. Cosecant squared x minus 3 cosecant x minus 28. Okay, so they got a little squished. We'll sub out the cosecants. Call them a's. So a is equal to cosecant x. So I end up with a squared minus 3a minus 28. This is just a regular quadratic, just like this one here. So find what multiplies to 28 times and adds to 3. So that would be negative 7 and positive 4. So this turns into a plus 4, a minus 7. Put back in what a was. So it's cosecant x plus 4, cosecant x minus 7. All right, so you may need to review factoring here. but it's very, very important. 1 is 2 cos squared x plus 7 cos x minus 4. Sub out the cosines if you want. Call them a's again. I end up with 2a squared plus 7a minus 4. Now this is a different type of factoring. Where you multiply the first and the last. So I go 2 times negative 4 is negative 8. And then I go, okay, what multiplies to negative 8 and adds to 7. So that would be 8 and negative 1. 8 and negative 1 adds 7, and they multiply to 8. So this becomes 2a squared. This 7a splits up into 8a minus 1a minus 4. Because this bit here would still add to 7a. And then, hopefully you remember, bracket the first two, take out a common factor, which would be 2a, and you a plus 4, factor out something, a common factor from here, which is negative 1. I get a plus 4. You know you're doing it right if these brackets match. And so it becomes 2a minus 1, a plus 4. Put back in what your a's were. So it's 2 cos of x minus 1 cos of x plus 4. And that's the factored form. I would really encourage you to do number 1 right now. Because the first step in every single question is going to be factoring. And once you've done that, go to page 600. We are going to do the first example, which is 2 minus squared x equals 1 minus x. Okay. They want the general solution, or they want you to solve it when x is between 2 pi and 0, and they want the general solution. Okay. So, first bit. They're on separate sides of the equal sign, get everything to one side. So, put over the 1 minus sine x, that's going to become plus sine x, and this 1 will become minus, and it all equals 0. Now, once you have everything to one side, you factor just like every single quadratic. I'll do it one more time with substitution. Okay, e is equal to sine of x. So I get 2a squared plus, oh my gosh, sorry, plus a minus 1 is equal to 0. Alright, remember, multiply first and last. So I get negative 2, and multiplies to negative 2 and adds to 1, to negative 1. So this splits up into 2a squared plus minus 1a minus 1 is equal to 0. Bracket the first two, I can take the 2a, I get a plus 1. Take the negative 1 from the second two, a plus 1. So this is 2a minus 1 and a plus 1. Remember, a was sine x, so it's 2 sine x minus 1 and sine of x plus 1 equals 0. So to solve this, you set each bracket equal to 0, just like we did way up here. When I solve the quadratic, add these two brackets, I essentially just go x plus 2 is equal to 0, therefore x is equal to 2, and x plus 1 is equal to 0, therefore x is equal to negative 1. It's just like finding the x-intercepts like in the polynomials unit. So what happens here is it's either 2 sine x minus 1 equals 0, or sine of x plus 1 equals 0, and you have to solve both. Now, if you're if you remember, so I'm going to do this one first. Sine of x, I move the 1 over, equals -1. If you remember from the last lesson, I said if it equals -1, +1, or 0, using the graph is actually the easiest way to solve it. Because where does sine x equal -1? Right there. What number is that? That's 270 degrees. So x is equal to 270. There's one of our answers. For this one, I move the 1 over, sine x is equal to 1, divide off the 2, and this I have to use my reference angles and all that. So we go, okay, sine, where's sine positive? Add sugar to coffee, and it's positive in the first quadrant and the second quadrant. And I find my reference angle, and I do that by doing the inverse sine of 1/2, which will spit out 30 degrees. Make sure that's right. Sure it is. Yes, it is. So that means this is 30 and that is 30. So what does x equal? It equals, to rotate there, 30 degrees. To go all the way to there is 180 minus 30, or 150 degrees. So my answers are 30, 150, and 270 degrees. Now, notice it was in rads, so I can convert these to rads. Hopefully you remember 30 pi over 6. How many 30-degree angles are there in 150? Well, there's 5 of them. That's just 5 pi over 6. And 270, hopefully you remember, is 3 pi over 2. It's 3 90-degree angles. There's my answer in rads. That gives me all the solutions between 0 and 2 pi. All right. If I want my general solution, then I just take these, pi over 6, 5 pi over 6, and 3 pi over 2, and I add multiples of the period. What's the period of a sine function? It's 2 pi. So I just go n 2 pi, n 2 pi, n 2 pi, and that is it. And there's your general solution. Okay, so essentially, once you factor generated first-degree equations, which is what we did in the previous lesson, and you solve them using the techniques we did before, you can get your answer over a restricted domain or a certain domain, and you can calculate the general solution by adding multiples of the period. All right. One more example, and then we are done. So same page, bottom of the page 600, we'll do a tan graph. So we have tan squared of x plus tan of x is equal to 0. Again, if you want to get rid of the trig functions, you can do a substitution. A is equal to tan of x, so this turns into a squared plus equal to 0. To solve that, you factor out an a, and I get a plus 1 equals 0. Excuse me. Put back in what tan is, or what a is, and it 1 0. Okay. Put them both off. Either tan of x is equal to 0, or tan x plus 1 is equal to 0. All right, well, tan of x is equal to 0. Now, who remembers the tan graph? Because it's a 0. So, tan graph, remember, looks like this. And that was 90 degrees. And this is a really bad tan graph, so I'm going to redraw it. Draw it up here. comes up, goes through the origin, asymptote at 90, asymptote at 270. Okay, so where does the graph equal 0? Well, hopefully you can see there, there, and there. Those are the x-intercepts. So that means x is equal to 0. That's 180. It's halfway between. And that is 360. If you were doing that the other way, where you figure out the quadrants, it would be a reference angle, 10 to the minus 1 of 0, which is going to give you 0. That means you're there, we're all the way around 360. So 0, there's 180, then come all the way around again, and you get 360. So there's your three answers. Now, the second bit here, doing purple. Tan of x, move the 1 over, equals -1. Now, you can't do that off the graph. It's a little trickier. So we're going to use our add sugar to coffee. Where's tan negative? Add sugar to coffee. Tan isn't positive in the first and third, therefore it's negative in those two. Find your reference angles, which is going to be 10 to the minus 1 of 1. Remember, ignore the negative. And you're going to get 45 degrees. Oops. 45, 45. So that means x is equal to, rotate to there, is 180 minus 45, which is going to be 135. And all the way to there, 360 minus 45 would be 315. Okay. So all of our answers, I'm running out of room already. So our answers are x is equal to these three, 0, 180, 360, 0, 180, 360, and those two, 135 and 315. So we actually have 5 answers on the domain 0 to 180, or 2 pi, sorry, 0 to 2 pi. Now, if they ask for the general solution for this, remember you take all these answers and you just go multiples of the period. But for a tan graph, what is the period? Hopefully you remember, it's 180. So where am I going to write the general solution here? I'll write it up here. The general solution is going to be 0 plus n 180. It's going to be 180 plus n 180. If you go in chronological order. 360 plus n 180. 135 plus n 180. And 315 plus n 180. All right. So you just take all your answers and add multiples of the period. The only trick is if it's a tan graph, the period is 180, not 360 or 2 pi. And if these were in rads, you'd just write 0 plus n pi, which is 180, plus n pi, 360, 2 pi, plus n pi, etc., etc., etc. Okay. The questions I want you to do for this lesson are, say, page 602, number 2, and C, and number 3. That is it. That is 2B and C and number 3. All right, people, good luck.